Okay, let's begin. Anyone who is not yet online at this point, I will assume the person is not really serious, or let me not say the person is not serious, maybe the person is caught up somewhere with some other activities. Okay, so let's just start, and whoever wants to join us along the way can join us. Like I said yesterday, we'll be talking about computer networks. So this is like the foundation of cybersecurity. Normally, I'm not supposed to have taken this particular topic. I feel most of us are just getting new into cybersecurity, and it will not be fair to just go straight to cybersecurity and start doing stuff. You might find some of the things very, very strange if you don't get this knowledge of networking, if you don't get this foundational knowledge. Okay, so we're going to discuss, I think we'll take about 3 sessions today and next week, Friday and Saturday, to discuss networking and what it's all about. This I want us to really pay attention to every single thing we'll be discussing under this computer networks. Is very, very important. If you don't grab this, you might find it really challenging when we start doing some stuff during the cybersecurity proper. Okay, so what is a computer network? Before I start, for the app, I believe by now I think it's better now compared to the first time we were using it, the Zoho app. So I think most of us were getting familiar with it, and I think it's, from what you have seen so far, you say it's better. It's a good app. We're going to continue with it. So what I did is, for your registration for this class, is going to cover for the rest of the classes, rest of the sessions that we'll be having. So you don't have to always register again. So what you do every Friday, you just get a reminder to join the class, and you can still use that same link to join the class. So you don't have to be registering every class. I think that is good, right? Because even me, I find it very uninteresting that for every session you have to register and join, register and join. Some people are already getting fed up with that. So for this particular class, if you registered for this particular class, you don't have to register again in the next session. Okay, please, confirm in the Q&A section if you can hear me. So someone is complaining. Someone is complaining that they cannot hear me. So please confirm in the Q&A section if you can hear me, so that I would know if it's just from the person or it's a general stuff. Okay, so I think they can hear me. So if you cannot hear me, you can log out and try to log in again. Yes, you can log out and try to log in again if you cannot hear me. So I believe it's just from your end. So let's carry on with the class. So we're discussing computer networks, and like I said, I would like you to really pay close attention to this particular class, okay? Because this is what computers, this is what the computer cybersecurity rather is all about. Okay, it's all about securing networks and securing the data that is being shared on that network. So what is a computer network? A computer network is a group of interconnected devices. These devices could be computers, they could be servers, they could be uh, your phone, ATM machine, that is a machine we use for withdrawing money. Okay, the automated teller machines. It could be anything at all. If you understand the definition of a computer, you know that a lot of things are computers, which we don't really, in a layman sense, might not classify as computer. So, computer network is like a group of interconnected devices, okay? And these devices must be able to share resources and information. So that is one of the key things to note in computer networks. Devices are able to share resources, they are able to share information. Okay, an example of such computer networks, we have the internet, then we also have home network. Maybe within your house, you can connect computers within your house. Even presently, we have televisions that use internet. So you have your router, your television is connected to the router, your phone is connected to the router, your computer is also connected to the router. So that's like a home network. Your home theater, your sound system, they are all connected. We also have like uh, smart houses where the window blinds are all automated. So everything is connected. Okay, so and this connection, they will have to share resources, they will have to share information. So let's look at types of network. After this class, I'm going to send you a book on this that you can read. The book will be more comprehensive than what we are doing here. So at your own free time, you can go through the book and gain more knowledge from the book. Okay, so let's look at types of network. We have the LAN, which simply means local area network. Okay. This type of network covers a small geographic area like an office or a home. Okay, it's usually between 10 meters to 1 kilometer. So LAN network covers between 10 meters to 1 kilometer. That's the local area network. Then we have the WAN, which is wide area network, which covers a larger geographic area like cities. It covers areas like countries. Okay. Such example of this is the internet that we use. Okay. I believe someone is already maybe getting confused. Okay. When we talk about network, it's there can be a network that is not connected to the internet. Okay. Computers can be connected just to share resources, not necessarily connected to the internet. I don't know if we get this. Okay. We can have computers that are connected together on a network, but they are not necessarily connected to the internet. And at the same time, they can share resources. Okay. So we have the WAN, wide area network, covers larger geographic areas like cities, country. Such example is the internet. It covers from 100 kilometer to 1,000 kilometer. Okay. So this is like a state. Like in a state, you might have a particular network that is covering that state, or even a country. You have some countries are not up to this 1,000 kilometers. So if you have a country that is covered by a particular network, okay. Then we have the MAN. MAN simply means stand for Metropolitan Area Network. Okay, connects network in a city, covers a maximum area of 10 kilometers. So this is less than the one. MAN is less than the one. Then we have the PAN, Personal Area Network. These are things like the Bluetooth or the infrared. Infrared, somehow most of us might not know it is getting phased out. Uh, Infrared is a technology that is getting phased out. Sorry, let me quickly attend to someone saying I could not join the class. How can I join? You have to register before you can join. Okay, sorry for the break in transmission. Let's continue. So we have what we call network topologies. Okay. Um, all of these are very necessary when it comes to cybersecurity because you have to understand what type of network, okay, just like the one we just finished, what type of network is it a local area network? If there's a breach, if there's like a system have been hacked, okay, you have to understand the type of network that was hacked. Was it a local area network? Was it a metropolitan area network? Was it a wide area network, or was it a personal area network? So you have to understand the type of network. So all of this is very important when it comes to cybersecurity. So we have what we call network topologies. Okay, network topology talks about how the devices are connected, in what format are they connected, okay, the manner in which the devices in that network are connected. Okay, and mind you, when we're talking about these connections can be physical, they can be wireless. Okay, they can be connections via cable, or they can be wireless connections. So we have what we call point-to-point connection. In this situation, is just two computers connecting with each other and communicating, sharing resources. Then we have what we call the star uh, topology. Okay, if you look at the diagram on the screen, you see the diagram of a star topology. So the server is at the center. Meanwhile, we have computers connected to the server, like in form of a star. Okay, so we have the star topology, we have ring topology, we have the mesh topology, and we have the tree topology, we have the hybrid topology. Okay, for the mesh topology, every computer is connected to each other. Every computer on that network is connected to each other. Like each of the computer is a server on its own. So there's no central server when we're talking about the mesh topology. Each of the computers, they are linked to each other. Okay. Then the hybrid is combination of different topologies put together. That's what the hybrid is all about. So these are just like patterns in which computers are arranged. Are they arranged on a line? Are they arranged zigzag? So topology is just how the computers, the manner in which the computers are arranged. Okay, so next we're looking at network protocols. Okay, network protocols. Just like we have the highway, just like we have road networks. Okay, there are protocols. We have traffic light that will tell you, okay, it's time for you. If it's showing green, you pass. If it's showing red, it means you should wait for the other people to pass. So also in network, in computer network, we have the same thing. There are protocols to the way computers communicate with each other on a network. Okay, so these are like rules and conventions for communication between network devices. So if you are a device, if your phone or your computer or your television or whatever device you're using is on that network, it has to obey these protocols for a proper communication to take place. Okay, so some of these protocols, we have things like the HTTP, we have FTP, we have a DNS. We have DNS simply means domain name system. Okay, that's what you use when you're browsing. Normally when you want to browse, you just go on the browser and type the name of the website. Okay, in real sense, in computer sense, the computer does not really see that name that you are typing. What the computer sees is an IP address, which we're going to get there in no distance time. We'll be looking at what IP addresses are. Okay, so we have different protocols that are responsible for uh, communication on a network. Okay, and this is very important. These protocols are very important. If there's no protocol, even on the road, if there are no protocols, there are going to be accidents. Okay, if there are no protocols, you might send information, you might send an information to a particular person and it will not deliver to that person. It might deliver on another computer. So there need to be these protocols. Okay, and these protocols, they also help to make sure the network is a little bit fast, so that when you send something, it delivers to the right person and on time. Okay, so these protocols are very, very important. So what are the some of the benefits of networking when it comes to in tech or in real life? What are the benefits of having network? Okay, okay, when devices are networked, they can share resources. Okay, when devices are networked, they can share resources. Like in most offices now, they have like a central database where they store their data. So if you are connected to that network in that office, you have access to that data. Okay, so you can share resources. If you need a particular file, you don't have to start asking so person, okay, I need this file, can you get it for me? You just go to the database from your own computer and fetch such such data. We also have printers, computers share printers. This happen mostly in offices. So if you want to print, you can just send your stuff to the printer if you are connected to that network. So everybody on that network can share the same printer and print their stuff as of when they want. Then data accessibility. Okay, when computers are networked, they have centralized access to data. Communication via email, you can do video call. These are some of the benefits of having of networking. Okay, cost effectiveness, reduce hardware expenses when when devices are connected on a network. So in networking, we have what we call the OSI model. Okay, OSI simply means open system interconnection. Okay, so this is like a model that um, like a framework or a standard that guides network communication. Okay, just like we just talked about protocols. Okay, in this OSI, you're going to see how each and every of those protocols actually function. Okay, when you are communicating, your communication is usually classified based on different layers of this OSI model. Okay, and the purpose of this OSI model is to help you understand how data travels across the network. Okay, and this is also very important when it comes to cybersecurity, because if you don't know how data is traveling across the network and they are telling you there was a breach or the data was stolen or someone was able to access the data, you might not really understand what they are talking about. So again, you see why we need to look at this particular topic of networking, okay, as the foundation of cybersecurity. Okay, because cybersecurity is all about defending network. Okay, you can't defend a network that you don't understand. It's all about defending the data on that network, the information on that network from an attacker. Okay, so this OSI model that we are talking about is made up of 7 layers. Okay, it's made up of 7 layers. You have to get used to these layers. I don't know how you do it. If you have to cram it, you cram it, because as you progress in this course, in fact, in the world of tech in general, you have to understand this model, this OSI model, okay, and how it functions, because this is what communication, this is what networking, computer network is all about. Okay, so we have what we call the physical layer. Okay, on the OSI model, we have what we call the physical layer. That is like the first layer. Okay, the first layer. This one is responsible for transmission of raw bit, those ones and zeros. is what the hardware understands. The physical layer is what your hardware, that's the message that your hardware understands. Okay. You now as a human being, you might not understand what is happening at this physical layer. It's the ones and zeros. Okay, then we have the data link layer. This is where we have frames. You know, uh, data is usually divided into frames. Okay, when you send data over a network, it is broken down into frames, into fragments. So it is those little fragments or frames of data that are sent. It can even go through different routes. Don't worry, as we progress, you'll see how this works. That data you're sending is broken down. If you're sending a video to someone on the network, the video is broken down into different frames. It is when it gets to the destination, as the person receiving it, that everything is built back together as one video. As we progress, you'll see how it separates and how uh, it comes back together, how it knows that okay, this particular frame is supposed to fit into this portion, this particular frame is supposed to fit into this portion, and there is no the video does not get scattered, or maybe particular frame that was supposed to be at 1 minute is now at 4 minutes. So as we progress, you will see how all of this work, which is also the which also goes back to protocols. Okay, those are those are some of the functions of protocols. Okay, we have what we call the MAC address. Okay, every device, okay, on a network have what we call a MAC address. Okay, apart from the IP address, every device comes with what we call the MAC address. Okay, this MAC address is what, like, that's what helps. If I want to send something to a particular person now, let's say I want to send something to maybe Abdullahi. Okay, I want to send something to Abdullahi's computer. What will help me in locating Abdullahi's computer is the MAC address. Okay, once I send, the protocol will search for Abdullahi's MAC address and make sure this particular information is delivered to that MAC address and not another person's MAC um, address. Then we have the layer 3, which is network layer. This is where routing, IP addressing happens. Okay, routing is like deciding which road. Okay, let's say we are on a network now, we're sharing information. What routing does is it decides which route is the shortest. Okay, if I wanted to go to Lagos, you know, there are from Abuja to Lagos, there are many routes that lead to Lagos. So routing will quickly check the network and decide which road is faster from Abuja to Lagos, which road is free from traffic. Okay, so to do that, you need to know the destination IP address, who is receiving this information that this person wants to send. So you first of all need to know that information, then look for the fastest possible route that will take that information to that person without any delay. Then we have the transport layer. We have the transport layer. This transport layer handles TCP and UDP. Then it also handles error. It also handle errors. Okay, if in case during the sharing of the data there are errors, it is the transport layer that will figure this out. What type of error is this, and how can this be rectified? Then we have the session layer that manages sessions. Okay, let's say you are like this particular session we're having now. I'm sharing my screen with you. So it is the session layer that is handling this particular session. Now I'm making sure what I am displaying on my screen is also displaying on your screen without any mistake. Okay. So that is the function of the session layer. We have the presentation layer where the data is translated from that physical layer, ones and zeros, to the in such a way to a human understandable to a form of data that humans can understand, because humans don't know what ones and zeros are. Those are computer languages. So when I send an information, what my computer does, it converts that information to ones and zeros, sent to your own computer. Your own computer converts it back to presentation, a way that you can easily view it and then present it to you using the application layer, which is the user interface. And in this situation, we are using what? Zoho app. Okay. So there's more note on this. Like I said, there's a book I'm going to drop on the Google Classroom. You can take your time and read. You get more understanding of what this OSI model is and what it really entails. It's very interesting. It's, as you read more of it, you get to like tech more. You get to like cybersecurity. You might even want to just stay on networking. You might not want to progress to cybersecurity again. Okay. So after the OSI model, the people that came up with that model, okay, they looked at it, they say, okay, this looks a little bit more complicated. Okay. You know, in OSI model, we have 7 layers. So they decided that, okay, let's try to break this thing down. Let's try to merge some of these layers. So they broke it down into what we call the TCP IP model. So the TCP IP model is made up of just 4 layers instead of the OSI 7 layers. Okay, so in the TCP IP model, some of the layers are merged together to form one layer. I don't know if that is clear enough. Okay, so in the TCP IP model, transmission control protocol, TCP means transmission control protocol, and the IP is stand for Internet Protocol model. Is a simpler model used for internet communication. Okay, the layers in the TCP IP models are the network interface. We have the internet layer, we have the transport layer, and the application layer. So you see that everything has been reduced to just 4 layers. Okay. So as we progress, you see which of the layers were merged together to form uh, other layers. Okay, so looking at this diagram on the screen here, you can see the application, the presentation layer, and the session layer in the OSI model are merged together to form the application layer in the TCP IP model. Okay, then the transport layer still remains the transport layer. The network layer in the TCP IP model is now known as internet layer instead of network layer. Meanwhile, the data link layer, okay, the data link and the physical layer have been combined to form the network interface layer in the TCP IP model. Data link and physical layer are combined. Application, presentation, and session layer are combined to form one layer. Okay. So what are some of the key differences between these two models? The OSI layer has 7 layers, and it is more abstract, more explanatory. Okay, TCP IP model have just 4 layers, practical for the internet. Okay, and each and every one of them have their pros and cons. That is the advantages and disadvantages, which you can read in the book I will share on the Google Classroom. Why do we need to understand these models, this OSI and the TCP IP model? Why do we need to understand it? Why is it important to cybersecurity? Okay, number one, it helps in diagnosing network issues. If, as a cybersecurity professional, if you don't understand these models, in the situation where there is a challenge, maybe your network was hacked, it will be difficult for you to really understand, to really diagnose what is happening on the network. If you don't know what uh, the OSI model, you don't know what the TCP IP model is, you don't even know what networking is. So that is why we are looking at this particular topic. Okay. Number two, the essential for understanding packet transmission and routing. Okay, so you need to understand how packets. Okay, when we're talking about packet, we're talking about information, we're talking about data. When it comes to tech, packet information, they are data that are transmitted over a network. So this OSI like TTP and TCP IP model will help you to understand packet transmission and routing. I already explained routing. Routing is deciding which particular route or in the network is best for sending a message to the destination. Okay, so this also forms the basic for understanding network security measures, because this is where you have all the protocols. Okay, so if you look at this diagram on the screen, you see they were mapping the OSI model to real world devices. We're going to look at these devices shortly. Okay, we'll be looking at some of these devices shortly. Also, if you see any of the device you don't really know what it is, don't worry, we'll look at them shortly. Okay, so for the physical layer, you can see most of the devices at this layer are just like the Ethernet cable. Okay, we have media, we have signal, we have binary transmission, all of that. Binary is talking about binary numbers, ones and zero. That's what I've been saying all this while. Then we have the data link layer, where we have MAC address and MAC address of the router, MAC address of the whatever device that is being connected to that network. Okay, so this is, if you look at, for each layer, there are devices that are working at that layer and the type of protocols that are being observed at a particular layer. Okay, every layer have their own protocols and the type of data, the type of devices that are working at this layer, up to the application layer, where you will now have, you can see a browser is being opened and they are using an application to view what each and every of these layer have transmitted and converted into what you as a human being can now read and understand. Okay, so we're going to be needing some of these tools later in the course as we are going. We'll need Wireshark. I think Wireshark comes with your Kali So if you have installed your Kali, you should have Wireshark on your Kali. So you don't need to go and start installing Wireshark again. So that's one of the essence of installing that Kali. Okay. So we're going to be looking at some of these tools and how the network really functions. When you open this tool, you'll see how your network is functioning, the strength of the network. With Wireshark, you can trace where information, what is coming to your computer, where it is coming from, which IP address it is coming from, what type of data is being sent to you. You can analyze uh, the network using this Wireshark. Okay, so identify data flow through the OSI layers using network tools. So this is one of the tools that we're going to be using. This image is still displaying the same thing we just viewed in the last slide. It's still the same thing, showing you what is happening at every layer of the OSI model. Okay, and the type of protocols that are being observed at each layer. For every layer, there's a particular protocol that is being observed. This is how information is shared on the network. This is how information is shared on the internet to make sure that you enjoy whatever you are doing on the internet. Stuff did not exist, it would have been very difficult for us to communicate on the internet because there will be a lot of conflict. Like you will just send your data or video and it will appear in another person's phone or in another person's computer. But with this, it is able to separate, know where this particular data is supposed to go and who is supposed to receive it. Okay, so this is uh, a screenshot from Wireshark application. This is how it looks like. Maybe by next week, or if time permits, we might still look at it today and see how data, how you can use it to analyze how data is network traffic, see how data is being transmitted on the network. Okay, so it's very simple. The processes are just very simple, and by the time we open the Wireshark app, you get to you understand better. Okay, so this is the end of this particular lecture. I think our next lecture is supposed to be devices. Okay, I'm going to send this assignment on the Google Classroom. We'll do it and submit it before Friday next week when we'll be having our next class. So you are to research and write a brief summary of how firewall functions across the OSI layers. Now, in the OSI, we have 7 layers. So you tell us how the firewall functions across each of these layers. First, you start by defining what a firewall is. What is firewall, first of all, and how does it function in each of these layers? I will drop the assignment on the Google Classroom. Then, secondly, I would like you to download this app, um, Packet Tracer. I will send you the link to which you can download the app. Okay, download Packet Tracer on your computer because we'll be using it next week. Then you read chapter 4 on firewalls and routing. of the Computer Network Plus. I'll send the book to you. So these are the 3 assignments you are doing this weekend. I think the assignment are supposed to be 4. There's also an assignment on CTF. So you have 4 assignments which you're supposed to submit by Friday, on or before Friday, on the Google Classroom. Okay. So I'll drop that on the Google Classroom. So I'll stop sharing my screen. That's the tools. Today we have a few number of persons joining us. Just 15 persons in class. That is interesting. And on the Telegram we have 80, or if not even more. Okay, so if you have any question,